Hey guys, it's Miss Vinson. So we've talked and learned about equilibrium, which is really important because we're going to do a lot of things with equilibrium today. We're going to talk about different ways to be able to predict how equilibrium price and quantity is going to change whenever there's something that shifts the supply curve and something that shifts the demand curve. Now, there are really three scenarios that we're going to talk about. The first scenario is really easy. It's when something happens and it only affects supply or it only affects demand. Suppose we're talking about something like oranges. Say that, a lot of oranges are grown in Georgia and Florida. So suppose that there was a big hurricane that came through the southeastern United States and really demolished a whole bunch of these orange tree plants. So just whole fields of orange trees were demolished. So we have a situation here where the supply has decreased, but the demand hasn't really been affected. So here's what we're going to do on situations like this. If you're just changing the supply curve or the demand curve, here's your steps. On your graph, you want to always start off with your original equilibrium. Because if we're trying to figure out how our equilibrium price and quantity changed, then you need to know where you were to begin with. So go ahead and draw your X, your upward sloping supply curve and downward sloping demand curve, and please do something to indicate your original equilibrium. Whether you put a circle there or a heart there, just something to draw your attention. Now, if we had something that demolished all these orange trees, then we said that that is going to decrease the supply of oranges. So remember, if we're going to decrease the supply of something, we're going to shift that whole entire supply curve to the left. So go ahead and do that. Draw another supply curve, S2, on your graph that has shifted to the left. Don't forget to draw your arrows showing that it shifted horizontally to the left. Now, when you drew that new supply curve, did you notice the new intersection point that was created? Notice that now there's a new X on our graph where S2 and D1 intersect. That is our new equilibrium. Go ahead and put a heart or a star or a circle there at your new equilibrium so that you can draw your attention to that on your graph. Now look what happened to your equilibrium price. It's higher. Well, that makes sense, right? We know that whenever there's less of something, they tend to be more expensive. So since there's less oranges are going to be more expensive. And of course, take a look at what happened to equilibrium quantity. Our new equilibrium quantity is less than our previous equilibrium quantity, and that also makes sense because if there's a decrease in the supply of something, that means there's going to be less quantity available. So in this case, we shifted our curve, we found our new equilibrium, and we saw that our equilibrium price went up and our equilibrium quantity went down. So we would be able to predict in this situation that equilibrium price would increase and equilibrium quantity would decrease. Anytime you have a situation where just supply or just demand is moving, one or the other, then you always want to graph it. That's really the easiest way to predict what's going to happen to equilibrium price and quantity. Now, the second scenario that we're going to talk about is when both supply and demand are moving and you know which one is moving more than the other. So suppose now we have an instance where demand is increasing more than supply is increasing. Suppose that consumers are getting paid a lot more, consumer income goes up, so now people are just buying a whole bunch more stuff because they can afford to. So let's say that demand is increasing a good bit, and supply is increasing as well, but just a little bit. Maybe there's a little bit of a better technology that allows the supply curve to shift to the right just a little bit. So both supply and demand are going to be increasing for different reasons. Consumers and producers are both going to be affected, but consumers are increasing their demand more than suppliers are increasing the amount that they're making. For this scenario, like we said, we want to go ahead and start off with our original equilibrium. So go ahead and start off your graph with your upward sloping supply curve and your downward sloping demand curve. Go ahead, label everything, and indicate your equilibrium, your original equilibrium. Indicate means that I want you to put some dashed lines showing it, or put a circle, something to draw your attention to it on your graph. Well, since we know the difference, since we know which one is moving more than the other, I want you to exaggerate that on your graph. So we're going to shift the demand curve to the right, but since it's the stronger force, really take that demand curve and shift it to the right. So draw a D2 on your graph that's way further over to the right. Now we also have to shift our supply curve to the right because supply is increased, but remember our increase in supply was just a tiny little bit. So take your supply curve and shift it to the right, basically just enough to say that you shifted it to the right. Most important is that you have it labeled S2. What we want to look at now is where our new demand curve and our new supply curves intersect. And that is going to be your new equilibrium. So put a circle or a heart there, something to draw your attention to the fact that that is your new equilibrium. Now let's compare your new equilibrium price and quantity to the one that you started with. Notice that your equilibrium price is a lot higher, so equilibrium price did rise. And also notice that equilibrium quantity is also further out, so equilibrium quantity is also greater than it was before. So in this case, guys, when demand increased more than supply increased, we saw that both equilibrium price and equilibrium quantity rose. So we would be able to predict that equilibrium price and quantity would be higher if demand increased more than supply increased. Things would be more expensive, but there would be a greater amount of things available. All right, in scenario number 3, we have both supply and demand moving, but the question doesn't tell you which one is moving more. So in these questions, guys, all it's going to say is demand and supply are both increasing, and it won't tell you which one is moving more than the other. Since you don't know exactly how to draw your graph, then that means that there is going to be an indeterminate in your answer. Basically, what we're saying is until we know which one is stronger, demand or supply, we are not going to be able to determine what's going to happen to either price or quantity, one of those two. Suppose I said that demand goes down and supply also goes down. Now, if I gave that problem to a class, here's probably what would happen. I would have one student, we'll call them student A, and they get to work on this problem. They say, okay, I can do this. I know I'm going to graph this. And so they start drawing their graph. They start off with their original equilibrium. They indicate it. Their graph is labeled. It's beautiful. And they shift their demand curve to the left. They shift their supply curve to the left. And maybe they were a little heavy-handed when they shifted their demand curve to the left. So when they found their new equilibrium, they noticed that equilibrium price fell, and so did equilibrium quantity. But I could have another student who takes a look at that problem and they graph it as well. And so they start off with their original equilibrium. They have everything labeled, supply and demand, original equilibrium, and then they decide, all right, I'm going to shift my supply curve to the left. I'm going to shift my demand curve to the left. Maybe this student was a little heavy-handed with the supply curve. So if they shifted the supply curve to the left more than they did the demand curve, then they're going to end up with an equilibrium price that's actually higher and an equilibrium quantity that's lower. So this student did the same thing as the other student. They both decreased demand and decreased supply, but they got two very different answers. One student said that price was going to go down and quantity was going to go down, but another student said that price was going to go up and quantity was going to go down. So what's the right answer? Until we know whether to make demand the bigger change or supply the bigger change, the bigger shift, we cannot determine what's going to happen to price. So our official answer for a situation like this is that equilibrium price is going to be indeterminate. We can't predict what's going to happen to equilibrium price. We can't determine what's going to happen to equilibrium price until we get that important piece of information. But look at what happened with equilibrium quantity. Man, no matter how you graph it, equilibrium quantity is falling. Now, I know you're thinking, ooh, in situations like this, do I really want to graph each of these twice to figure out which one is indeterminate? No, because I have a little trick, a little shortcut for you, all right? Now, pay attention because it's really spectacular. Actually, it's kind of cheesy, but I think it's pretty spectacular. It prevents you from having to graph any more than you have to. If supply and demand are moving in the same direction and you don't know which one is stronger, Put a line through that S, and that changes it into a dollar sign. If they're moving in the same direction, cha-ching, price is the indeterminate factor. So if supply and demand are moving in the same directions, they're both increasing or both decreasing, and you don't know which one is stronger, then instantly you know that same direction, price. Price is the indeterminate factor. So you're not going to be able to figure out what's going to happen to price, but you can graph and figure out what happens to quantity. But oh yes, it gets even better than that. Suppose that supply and demand are moving in opposite directions. So maybe in this example, demand is going up and supply is going down. So if they're moving in opposite directions, just take a line and put it through that O, quopposite, all right? If they're moving in opposite directions, quantity is gonna be your indeterminate factor. So let's do one of these examples together. Suppose that, like I just said, demand increases and supply decreases, but your question doesn't tell you which one is stronger. So immediately you know there's going to be an indeterminate in your problem because the question didn't tell you exactly beyond a shadow of a doubt how to draw your graph. Demand and supply are moving in opposite directions, so one of your factors is going to be indeterminate. What's it going to be? Quopposite, right? It's going to be your quantity. So right beside equilibrium quantity, put indeterminate there. Now that's only half your answer. You still have to figure out what's going to happen to your equilibrium price. All right, well in that case, guys, what you're going to do is you're going to graph it, but you're only going to pay attention to equilibrium price. Seriously, don't pay attention to what happens to equilibrium quantity at all. We know you can't trust your graph for equilibrium quantity. So when you draw your graph, just shift your demand curve to the right, shift your supply curve to the left. It really doesn't matter which one you make the stronger one. And when you shift your demand curve to the right and shift your supply curve to the left, you're going to find that that equilibrium price is definitely higher. No matter if you made supply the bigger change or demand the bigger change, both of those things are going to elevate equilibrium price. So in this case, when demand goes up and supply goes down, equilibrium price is going to rise and equilibrium quantity is going to be indeterminate because of quopposite. All right, so don't get confused on these things. Most of the time you can graph them. The only time you have this extra little rule to remember, and it's really not much of a rule, it's really just more of a shortcut, is when they're both moving and you don't know exactly how to draw your graph. Your question didn't tell you which force was stronger. In that case, you're either going to have them moving in the same direction, so price is going to be indeterminate, like your dollar sign, or they're going to be moving in opposite direction, so quantity is going to be your indeterminate factor because of quopposite. I know this is a little bit crazy, but sometimes we have to do some crazy things to make it click in our minds. So hopefully you understand this and you enjoyed this, and now you can predict what's going to happen to equilibrium price and quantity in any situation. All right, see you later.